Hello statistics student, this video is chapter 1.4, Experimental Design and Ethics. So in the first part, we're going to study some terms related to experimental design, statistical study. And then in the second part, we'll do some example and also look at ethics of good experimental design. So the first is about statistical study. So these are terms that you should know. So to give you a framework of different types of statistical study also. So there's two main types of statistical study. One is called observational study and the other is called experimental study. What's the main difference? In observational study, we observe and measure characteristics of the subjects. So notice the keyword is you just observe and measure. You can do a survey, you can do an observation. You do not attempt to modify the individuals being studied, so this being the sample. In experimental study, you apply treatments and then measure its effect on individual. So in an experimental study, a lot of time you are looking at how one things affect the others. So this very often involve applying some kind of changes to the individual in the sample. Examples of treatment would be for the individual to try new drugs that is being testing out and applied to the current situation. A treatment would be a new vaccine that you're trying to test to see if it helps to reduce infection of a certain disease, right? So a lot of time experimental study are used for that purpose. Observational study are usually just measuring data for the individuals. Sometimes you do not want to study relationship, but you could use data from observational study to study relationship. Out of observational study, there's also three types. One is a cross-sectional study. Data are collected at one point in time, not over a period of time. The second part is called retrospective study. Data are collected after you collect after you select your sample, but then you do not interview your sample or survey your sample. You just choose them, but you would go back to examine their medical record or whatever that they have done long times ago. Okay, usually medical records. Prospective studies are data collected in the future from cohort groups. So these are the study where you pick your sample, but you do not collect the data right away. You would see what happened in the futures. A very famous one would be the one that is done in New York, where a researcher wanted to study the effect of preschool student or on toddler. So toddlers are randomly assigned to take preschool versus not taking preschool. And then they would be followed for 12 years after they enter grade school. And after they graduate from high school, they measure their academic performance to see if there's difference in their academic performance for people in the two groups. So in this particular case, actually, you can see that they may be observational study because the fact that they are in preschool is not is not something that they have chosen. Is something that they have chosen, but it's not arranged by the researcher, so it's not a treatment that is done to the toddler. But you could actually randomly assign children to take preschool versus not preschool, and those would be called a treatment. Okay. Anyway, so these are the types of different study that you can label: prospective, retrospective, and cross-section. And when we do experimental study, you apply treatments. So the purpose of an experiment is very often to investigate relationship between two variables. The two variables or two data are named for it. Is named the explanatory variable. The variable that cause changes in another is called explanatory. The affected variable is called the response variable. Okay. Observational study can also study explanatory variable and response variables relationship, but it can only demonstrate an association, but no, you cannot do causal relationship. You cannot say that the explanatory variable caused it. Okay, a good experiment can actually control other factors that affect the result, affect the response variable by eliminating all the other confining variables. So let's look at what are some of the good features of a good experimental design. The three areas that constitute a good experimental design are control, randomization, and replication. Control is a statistical jargon, so you must have heard of a control group. Control group is the group that does not take the treatment. So the control group is a group that maybe sometimes they take the placebo. A better control is actually one that take the placebo instead of taking nothing. They take the placebo. And we can also improve the control group's results by using blinding or double blinding to reduce placebo effect. So there are a lot of jargons here. Blinding, what is blinding? Later I have here. Blindings are a situation where subjects are unaware if they are in a control or treatment group. They may be taking a treatment, but the treatment could be a placebo or a treatment, the real treatment. Double blinding are the one in which both the subject and the researcher involved in the subjects are blinded. That means they do not know the people that pass out the treatment would not know who is receiving the placebo or who is receiving the real treatment. So this reduces the chance of having the subject know about if they are in the control or treatment group. What happens if sometimes if the subjects knows that they are in a placebo group, they would know that, oh, I'm not going to get well, and it might affect the results. Or treatment will think that, oh, I am receiving treatment, I'm going to get well. So in using the blinding and double blind arrangement can reduce placebo effect. Placebo effect is called the power of suggestion. If someone gives you something, suggests that you will have some effect, you might think that you will. There's a huge study on placebo effect on people taking medication. So that's why some people say, if you go to see the doctor, you will feel good because you believe that your doctor will make you good. The second way of making an experiment good is randomizations. Just think about it. If you let patients volunteer to be in the control group or volunteer to be in the treatment group, so that might not work, right? So result may be biased. Maybe sicker people or sicker patient will be volunteers to be in the treatment group, or people that are less healthy would be in the control group. So you don't know. So in order to exclude features of the subject that might affect the results, the assignment of control and treatment groups should be random, and we call it randomization, and sometimes we call it completely randomized design. Sometimes it's not good to randomly assign patients to treatment and control group, but actually match them so that the control and the treatment group have similar health situation, similar gender, or in a extreme case, they are twins. So we also can, instead of completely randomized design, sometimes match pair design are used. Replication is a approach where we try to use a large sample size in both the control and treatment group. But this is an ideal. A lot of time when we are testing a new drug, say for example a new vaccine, no one knows if it's useful, no one knows if it's safe or not. You cannot recruit a big sample size. Okay, but these are the guideline for good experimental design. The three areas is control, randomization, and replication. So let's do an example. Researcher wants to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. So because they are randomly divided, so they are using completely randomized design. One group will take aspirin and the other group will take a placebo. Each man takes one pill each day for 3 years, but he does not know whether he's taking aspirin or placebo. So from the description, you can see that they are doing blinding. We don't know if they're doing a double blinding. At the end of the study, researchers count the number of men in each group who had heart attack. So the researcher will know who is in each group, but the man does not know. Identify the following value for this study. What is population? What is sample? Experimental units? Explanatory variable? Response variable? And treatments. Populations. So notice that they recruit men between the age of 50 to 84. So the population must be they're looking at the target of all men, and it is only men, right? So all men between, maybe all men in United States if it is done in a certain country, between 50 to 84 age. Samples are the 400 men recruited that participate. The 400 participants are the sample. Within experimental unit is each man, each participant. Each one of them is receiving a treatment. Each one of the men. Explanatory variable, they are trying to see how taking aspirin will affect heart attack. So the one that is causing it is taking aspirin or placebo. Response variable would be heart attack or not, right? If each experimental unit experience heart attack or no heart attack. Treatments are the aspirin or a placebo. So each one of them received this. I think the experimental variable is the medication. Yeah, you can also say the medication, either the aspirin or a placebo. Okay, so we have a second one and a third one. So maybe we'll do the last three parts in the second